Hi everyone. Notes 4.3 are on absolute value. I'm going to have you guys watch it today in class. Once you go through it, then you should be able to do the assignment. If you have any questions, let me know and I'll answer them tomorrow. We'll also finish the sign of X column tomorrow when I see you guys in class. A little bit through class today, Ms. Troll will come in and talk to you guys about university applications and stuff, but it'll only take about 15 minutes or so. So the first question that I have you looking at here is to evaluate m plus 6, the absolute value of m plus 6 minus 14, if m equals 4. So I'm going to substitute the 4 in right here. So I end up getting 4 plus 6 minus 14. And then right here, 4 plus 6 is 10. So it's the absolute value of 10 minus 14. The absolute value of 10 is 10. So 10 minus 14, the final answer is negative 4. Now, just a reminder, the definition of absolute value is the distance away from 0. And since distance is scalar, it only has it's never going to be negative. So right here, the distance away from 0, 10 is 10 steps away from 0, so we get 10. But it's possible to get a final answer that's negative if we have numbers on the outside of the absolute value expression that we have here. Okay, so just quick review. If we wanted to evaluate 23 minus 3 minus 4x, if x equals 2, then I'm going to take this 2 right here and I'm going to plug that in. So I get 23 minus the absolute value of 3 minus 4 times 2. And I'm going to follow order of operations inside of here. So I end up getting 23 minus the absolute value of 3 minus 8. So I get 23 minus the absolute value of negative 5 right here. Common mistake people will make, they'll say that this minus and negative will turn into a positive. But I need to evaluate the absolute value first. And the absolute value of negative 5 is positive 5 because the distance from 0 to negative 5 is 5 steps. So I end up getting 23 minus 5, which is 18. Okay? Now, if I'm writing too fast for you, you can go ahead and take control and you can pause and rewind and do whatever you need in order to be able to do okay for this video and get the most out of it. All right, so now we're going to get into something slightly different. So this time we're going to solve for x. So if the absolute value of x is equal to 4 right here, I want to know what x could be. Well, it's clear that x could be 4. But that's not the only answer. So I want to show you guys graphically what the other answer is. You probably can figure out what the other answer is, but I want to show you graphically why the other answer is the right answer. So going to Desmos, I'm going to start graphing. I'm going to graph out y equals the absolute value of x. And then I'm also going to graph out y equals 4. And if you notice right here, we have 2 intersection points. We have 2 answers. One of them is at positive 4, but the other one is at negative 4. And the reason why the other answer is negative 4 is because when you take the absolute value of negative 4, you still get 4. So x could be 4 or negative 4. Okay? But if we have something like this where we have the absolute value of x plus 5 equals 17, a lot of people will say the answer is going to be either 12 or negative 12, which is incorrect. And I want to show you graphically why that's incorrect. So instead of the absolute value of x, we're going to say the absolute value of x plus 5. And instead of 4, we're going to put 17 right here. And I'm going to zoom out a little bit so I can kind of see where my intersection points are. So my first intersection point is at 12, which we said would work. X would equal 12. But our second intersection point is at negative 22. So let's talk about why algebraically the second answer will be negative 22. So when I take the absolute value of something, that means that whatever is on the inside of my absolute value sign right here is either going to be positive 17. So that means that one equation is going to say x plus 5 equals 17, or the other equation is going to say x plus 5 equals negative 17. So once you isolate the absolute value, that's where you start to write your two equations, not after you isolate the x, okay? So in order for me to be able to solve a problem like this, I need to remove the absolute value bars. And the only way I can do that is by setting up my two equations that I have here. Once I do that, I can go ahead and solve for x. So I get x is 12 over here. And on this side, I end up getting x is negative 22. And that's why my two answers are 12 and negative 22, as opposed to 12 and negative 12, as shown in our Desmos graph right here. Okay? Okay, for the next question, I want you guys to solve for x if the absolute value of x plus 1 is equal to negative 3. And what I'd like you to do right now is I want you to pause your video and wait for the people around you, one or two partners around you, to also pause the video and discuss this problem with them and see if you can figure out what values of x will satisfy this equation. Once you've discussed it, come back to me and check to see how you did, okay? So essentially, this is saying that if you take the absolute value of some number, you'll always get negative 3, which is impossible because the absolute value of any number will never give you a negative 3. And graphically, if you want to see this graphically, you would just type in y equals the absolute value of x plus 1. Okay, and then in the next one right here, I'm going to go ahead and type in negative 3. And when I graph that out, so negative 3 equals y, when I graph that out, it will never intersect because y equals negative 3 will always be below the graph, okay? So that means that this ends up having no solution. It doesn't work, okay? All right, so next thing I'd like you to look at is an inequality. So we're going to consider the inequality absolute value of x is less than or equal to 4. So same thing, what I would like you to do right now is just think about what numbers could x be. Like I want you guys to actually think about actual x values. So what x values could you have? And same thing, once you guys get to this point, I want you sorry, could x be? Once you guys get to this point, I'd like for you to please discuss with the people around you some values of x, and then consolidate that and try to summarize what x could be, and then come back to me to see how to formally write your answers out, okay? So hopefully you've determined that x can be any number that's smaller than 4, right? But the problem is if I say x can be any number that's smaller than 4, then I could also say that x could be negative 5, for example. But if I were to take the absolute value of negative 5, I won't end up getting a number that's less than or equal to 4. So this does not work. Okay, but if I were to use 2, for example, that would be less than or equal to 4. So anything less than 4 works as long as it's also greater than negative 4. Okay, so for example, if I were to use negative 3, if I were to take the absolute value of negative 3, I would get 3, and 3 is less than or equal to 4, so that number works. So essentially, let's see graphically what it's going to look like, and then we'll summarize our information. So if you have the absolute value of x here, and then we have y equals 4, essentially, I'm trying to find where the black graph, the absolute value graph, is going to be underneath the horizontal line that we have here. And so that works anywhere between this intersection point and this intersection point. Anything to the left of this intersection point we will end up having the absolute value is greater than 4. And same thing with anything to the right of our intersection point. So that means that anything between negative 4 and positive 4 will work. Okay, so therefore my solution set, my answer to this problem is going to be anything between negative 4 and positive 4, or negative 4 is less than or equal to x is less than or equal to 4. That is my solution set right here. So if I were to graph out my solution set on a number line, then I would say my answer is anything between -4 with a closed circle and +4 with everything in between. And that works because all of these numbers right here, when you take the absolute value of it, will be less than 4. In interval notation, we're going to say that our answer, our solution, is from -4 to +4 with closed brackets because it includes -4 and +4. Okay? All right, so what I would like you to do next is to please consider the following inequality. The absolute value of x is greater than or equal to 4, right here. So if it's greater than or equal to 4, I want you again to think about what values of x could satisfy this. Talk to your partners and then come back to me and we'll figure out how to formally consolidate our answers again, okay? So this time, a possible value of x that could work might be 5, because if I take the absolute value of 5, I end up getting 5, which is bigger than 4. And anything above 4 will work, but also anything below -4 will also work. So for example, if I take the absolute value of -5, I still get 5, which is greater than or equal to 4. So if I were to look at this graphically again, I would see right here that anything to the left this time of my intersection point shows that the absolute value this time is greater than or equal to 4, and anything to the right of my intersection point will show that the absolute value of x is greater than or equal to 4. I'm not sure if I said -4 here, but I meant to say that. So this time our solution is going to say that x is less than or equal to -4, or x is greater than or equal to 4, okay? So if I were to demonstrate this on a number line, my solution set would now look like this. I would have -4, I would have +4, and anything greater than 4 will work, because all of these values, when I take the absolute value of it, will be bigger than 4. And anything less than or equal to -4 will also work, because if I take the absolute value of any of these negative numbers down here, these larger negative numbers, I'll still get a number that's greater than or equal to 4. Now, to write this in interval notation, I would say my answer is going to be from -∞ to -4, including -4, as well as +4 to infinity, including 4, but obviously not including infinity because we'll never reach infinity, okay? And that's my solution for that question. Okay, last question that we're going to take a look at is this one right here. Solve and graph the inequality below. So it says that the absolute value of 3 plus x minus 4 is less than 0. So I want to look at it graphically first. So if I take a look at what we have here graphically, we know that the absolute value of 3 plus x right here minus 4 is this red one right here, and then y equals 0 is this purple line that we have here. And I want to know when the absolute value is going to be less than 0. So I'm going to find out when it's going to be below this purple line right here. So that means that it would be anything between -7 all the way to +1. Okay, so graphically we can see our answer. Algebraically, let's talk about how to solve this algebraically. The first thing I need to do always is I need to isolate my absolute value before I can set up my two different inequalities. So I'm going to say the absolute value of 3 plus x is less than 4. Now, once I've done that, I end up getting two inequalities that I'm allowed to write. I'm allowed to say that 3 plus x is going to be less than 4 without the absolute value bars, okay? Or if everything inside of here is less than 4, then when I take the absolute value of what we have inside of here, all of these numbers inside of here are also allowed to be bigger than -4. Just like when we had this problem right here, we ended up getting that x is less than 4, and also x is greater than -4, and I should say equal to over here. Okay, it's the same exact idea. And I apologize, you guys, I wrote the wrong word down right here. This one is and, because it's possible for whatever number that we have here to be less than 4 and bigger than -4 at the same time. For this one, we said or because it's impossible for a number to be bigger than 4 and also less than -4 at the same time. Okay, so now that I've done that, I'm just going to solve each part. So here I end up getting x is less than 1, okay? And here I end up getting x is greater than -7. And it's true that x can be less than 1 and bigger than -7 at the same time. So if I were to look at this right here, our solution shows that it's anything between -7 and 1. So that means that my solution will be anything between -7 and +1. Okay, if I wanted to show this on a number line right here, because it says to solve and graph, I'm going to indicate where I have -7, it's over here, and then I have 1 over here. It can't be equal to -7 because it's just less, or it's just greater than -7, and it can't be equal to 1 because it's just less than 1, and it's everything inside of here. Okay, and then I'm just going to write my answer as in interval notation, and then I will be done with this question. So my answer is going to be from -7 to 1 with open brackets because it can't be equal to -7 or 1. All right, last thing right here. I just want to tell you guys that there's a slightly modified assignment. I want you guys to do page 16, 1 through 10. The assignment sheet says to just do 1 through 6, but tomorrow it says to do 7 through 10. But you should be okay with it because it's review from last year. It's just stuff with basic absolute value functions with 1 or 2 transformations. And the last 2 questions you'll be able to use Desmos for. So you should be okay for 7 and 8. Work together, help each other out, and I'll answer questions if you have any. If you have weekly reviews ready to go, make sure you hand those in. Those of you guys who handed them in yesterday and today, I'll have them ready for you with feedback tomorrow. All right, I will see you tomorrow. Have a great day. Bye.